one complete rotation every 24 hours. Using ancient man's concept that the Earth is stationary, we imagine the celestial bodies on the celestial sphere to rotate from east to west. In effect, we are creating a new reference system with your position at the center.
Yeah, from anywhere on the globe, you're going to be straight up and create a flat level plane and put yourself in the center.
We have used the sun as an example, but the apparent motion is common to all celestial bodies. Their hour circles are constantly rotating from east to west.
It is convenient to assume that we are at the center of a great sphere of infinite radius, and that the heavenly bodies move about us on this celestial sphere.
So how do you account for that globe rotation when you do celestial navigation from an airplane? It seems in the old days they never account for that rotation.
However, the advance in airplane design, bringing forth vast aircraft capable of sustained flight for great distances over large bodies of water as well as over land, has prompted the Army to adapt to aviation the navigational methods of the mariner, namely dead reckoning and celestial navigation, and to devise instruments to enable a pilot to accurately fly a given course. Among other things, student navigators are taught to fly entirely by instruments, to determine drift and ground speed by specially constructed instruments, and to determine position by sighting on celestial bodies with the bubble sextant.
Oh, latitude parallel flying without taking rotation and the tilt in account. Oh, MacArthur chart flying. Oh, a flat map and you draw straight lines. Yeah. Here, the sun in the celestial sphere. The virtual sun moves exactly 15 degrees in 1 hour.
The apparent motion of the sun is not uniform. For this reason, it would be difficult to construct a clock capable of keeping this irregular time. Therefore, a mean or imaginary sun is used.
Here is a 73 azimuth. And then an hour later it's 88 azimuth. And when we look at the observed sun from this location, then it moved only 8 degrees from 273 to 265. We cannot detect 15 degrees an hour from the observed sun. This app showed the observed sun, so this is what the people see and observe. Let's see how many degrees it moves, roughly. Here at 6, it had an azimuth of 55. And here an azimuth of 64. So that's 9 degrees. From 64 to 71. It's 7 degrees. And it moved again 7 degrees in an hour. Let's move from 78 to 85. And that's around the 8 degrees. 85. And again 8 degrees. Oh, and now 10 degrees. You cannot detect the sun going 15 degrees an hour. And on this day, the sun moves with these rates over a full latitude. It's all the same this day. It seems it cannot make a full rotation in 24 hours with this rate. So let's test it for the moon. Only the moon in the celestial sphere do 15 degrees an hour. Let me see. Azimuth. Let's take a rounded number. At 1700. The moon had an azimuth of 116. And an hour later, it has an azimuth of 110. So that's only 6 degrees. And now the speed even dropped 1 degree. And now it's 5 degrees in an hour. And again 5 degrees. So where is this 15 degree an hour motion? And it can even go faster, like 25 degrees in an hour. Azimuth 104 at 12. And now it's 128. So that's like 24 degrees. So we went from 6 degrees an hour to 24 degrees an hour. You see, moron? It happened right in front of your nose. Here, this one, do 110 degrees in an hour. From 70 to 323. That's 110 degrees. Only the virtual sun in the celestial sphere and the virtual stars move 15 degrees an hour. Not the observed real suns. Those don't do 15 degrees an hour.
Therefore, a mean or imaginary sun is used. This mean sun is assumed to have a uniform rate of motion with respect to the Earth. As the mean sun is imaginary and the true sun does not have a uniform motion, how then is correct time to be determined in actual practice? And that rate of motion is equal to the average rate of the apparent or true sun during a year.
I want to know all about celestial navigation. Let's watch this instructional video.
They gave this sphere a name, celestial sphere, and we still call it that today. On the celestial sphere, on the celestial sphere, the celestial sphere on the celestial sphere, celestial sphere on the celestial sphere. The celestial sphere has an infinite radius. On the celestial sphere, the celestial sphere has an infinite radius. You must recognize that the distances of space are so great that light from a celestial body arrives at the Earth in a narrow band of rays that can be considered parallel. When you note the altitude, you know you are somewhere on a circle of equal altitude.
Those lines are not very parallel.
You must recognize that the distances of space are so great that light from a celestial body arrives at the Earth in a narrow band of rays that can be considered parallel.
First you're telling us how parallel they are, and a minute later you show lines that can triangulate to a celestial body. So science telling us two different things. Looks like circle of equal altitude is just a triangulation. Don't tell me I cannot draw lines from outside that circle and make a triangulation. If we can triangulate a star that is many light years away, then we also can triangulate the sun and the moon, of course, because they are way closer.
To find your precise position on this circle of equal altitude, you must take an observation of another body to determine a fixed position.
Yeah, that's called triangulations to a single star from multiple locations. And the normal triangles have 3 straight sides and not a bendy baseline.
A third observation will confirm your actual position.
Oh, Mom, look! I made the celestial sphere with 2 locations in a circle of equal altitude. And I modeled up the virtual fake sun that only exists on paper and that makes the Earth round because it spins around in 24 hours. 2 locations in the circle of equal altitude. North 60, East 92, March 20 at 6 a.m. and here's 0 latitude north on the 31st longitude east. And the same time, 6 a.m. with exactly the same altitude. And we have the virtual computed fake sun with an azimuth of 268. That would be the 92nd longitude east, according to my tool. Here is the computed sun, and that sits on the 92nd longitude. And it had a declination of 0. That would be on the equator. 60° north, 92nd degree longitude east. With an azimuth of 180.1 and an altitude of 29, of course. And here the 31st longitude east on the equator. We set an azimuth of 90.2 and an altitude of 29. So those 2 lines on the circle of equal altitude don't triangulate like celestial navigation claims. Huh. Or you think you can correct them with this tiny bit of arc minutes and make those lines come together? 14.4 arc minutes is a quarter of a degree. And 60 arc minutes is 1 degree. We need about 12 degrees to line those up. 12 degree is 720 arc minutes. And that is only one motion. It seems we have to put more angles. And 15 degrees in this direction. And 15 degrees about 900 arc minutes. Altitude correction. Up and down. And not left to right. Do I see azimuth corrections here? No. I had to go in 2 ways. Up and down and left and right. Piece of shit.
The celestial sphere has an infinite radius.
Infinite radius. If I expand it, then the distances between those suns become also bigger, of course. Here, bigger distances. That's logic. If you expand something. And for the people that want to know how big that circle of equal altitude was, that was 8,400 kilometers. And if we move to the 152nd longitude east, 2 degrees north, where the sun have the same altitude, then the circle is of course bigger. Here I draw this line. Here at an azimuth of just under 270 west, and of course an altitude of 29. Here is the azimuth, and here is the altitude, 29. Here is the circle of equal altitude. This was 60 degrees north on the 92nd longitude east, on the 52nd longitude east, and the 31st longitude east. And this circle is about 13,000 kilometers. 30,443 kilometers according to the coordinate system. And again, as you can see, and again, the claim from Celestial Navigation and the Nautical Almanac is that these lines should come together and triangulate. Let's see how it looks like on what we call the flat Earth map. I never have modeled up suns on equal altitude on the clear suns. Maybe we have to do that and see where the sun is. I didn't model up other locations. This is only the suns around the circle of equal altitude. Here, this looks a little bit better. Even the location of that fake sun sits on the right spot. Yeah, look at this. Let's see where the sun is on the flat Earth map. 152nd longitude. It had an azimuth of 268. That was 268. With an altitude of 29, of course. Let's do the next one. On the equator. On the east 31st longitude. Azimuth is 90.2 and altitude is 29. Here we are. 29 and 90.2. And the last one, 60 degrees north, east 92 longitude. And the azimuth was 80.1. 60 degrees north, 92nd longitude east. .1 and 29 altitude. That's almost a triangulation. Looks way better than this trash. And this needs minor correction. So you two clowns think I mess up 4 videos on a row? Then you must be pretty stupid with your retard modeling, 2D clone modeling. Are you stupid? You both are retarded, and that whole group of yours. And now get lost. I don't want to see your face anymore on my channel. You lost the battle from one-man army Q, piece of shit. Make a video about me, because you promised that, piece of shit.
Celestial sphere again. The celestial sphere appears to be moving. There's a great circle on the celestial sphere.
There is no triangulation in celestial navigation. Clearly there is. What you think the circle of equal altitude is then? Huh? So this is clearly a triangle and not parallel lines like you claim. How can these lines be parallel? Or you think these lines become parallel if you extend the distance from the star? Did you ever see the lines of a triangle become parallel when you make it longer? This configuration shows a triangulation, idiot. And what you cry about scale? Typical case of the pot calling the kettle black. The celestial bodies in the celestial sphere have the same distance. Oh look, the moon, 240,000 miles, have the same distance as the sun, 93 million miles. Oh wow. And Saturn, 750 million miles away. And Polaris, 433 light years away. Yeah, this is really to scale. And it looks like we can triangulate celestial bodies. Look here. A triangle. And we can extend this celestial sphere to infinite, but the triangle always stay a triangle. So this moron thinks he can make the lines of a triangle parallel by increasing the distance. This one is mentally ill. Parallel lines. That never happened. They might look a little bit parallel, but they don't. I have here the moon in the celestial sphere, which is about 30 Earth diameters away from the Earth. My globe is like 200 meters. Those lines are 6,000 meters. So that's about 30 Earth diameters distance. And I have here 3 locations on the same moment modeled up. But where are the parallel lines? I don't see parallel lines. Do you? Let's see what these locations are. The moon on March 20th at 12 noon. First we have to place the virtual fake moon in the celestial sphere.
Therefore, a mean or imaginary sun is used, and is assumed to have a uniform rate of motion with respect to the Earth.
On paper we can make everything uniform, of course. Okay, let's measure my globe first. Diameter. You can see it in the right corner. It's 200 meters. But from a distance it's not very precise. But you cannot believe me. And those lines are about 6,000 meter. Okay, fake moon first. On 151st azimuth. And at a declination of 8 south. 8 south. First location, Equator, 180 degrees east, with the moon at an altitude of 60 and an azimuth of 107.5. Here we are. (107.5) and an altitude of 60. Let's do the next one. North 50, west 90. The moon at an altitude of 10 and an azimuth of 242.1. North 50, west 90. West 90. I'll leave it here for a moment so you can count the latitudes. Each line is 2 degrees. Let me center it for you. Zoom in a little bit. So go ahead. Count the lines. So you're done counting now? That azimuth was 242. .1 with an altitude of 10. So now I try to do everything in one go, otherwise you don't believe me. So we see this one. Let's go back. To the 180 longitude east. And here you can see it's still the same. My program is very precise. And an altitude of 60. Now let's move to the fake one. Where it is, here. 151st. Declination 8. Let me change camera angle again. So I did it in one go. So where are the parallel lines according to you? Where are they? I don't see parallel lines. You're full of shit. You can model this up yourself. I've done this hundreds of times. We can see this all the time. Or you think I'm miles off with modeling? People use it to build everything. So don't tell me I made mistakes of 5, 6, 7 degrees or 10 degrees or more. You can see that on my compasses and the lines. If they are off by a degree or 2 or 5. I show everything closely. I just debunk your ass. This is almost to scale. Moron. So, I prove you wrong here. I ask you what happened if I extend those lines. McCloud, idiot, my friend, holy sheep shit. Have a better eye than you. He's right about those lines. Maybe you can use models that are to scale. Piece of shit. So you morons think this is to scale. Retard. I have here the model from my previous video, untouched. I will zoom in on the locations and then you can compare with my previous video if something is changed. You claim parallel lines, let's see that. Location of the virtual star, unchanged. This was 174.5 I believe, but you can compare it yourself, and the altitude you know also. And now the last one. Nothing is changed here. I will change camera angle. And these are the extended lines. Yeah, they're parallel. Huh. That's amazing. Oh, I see this one is a little bit too short. I made it longer and I highlighted the lines. So these are parallel. I don't think so. What do you see from space? Lines that become wider. Do you see that? Do you see parallel lines as you claim? Or you think those tiny bit corrections will make those lines parallel again? 300 arc minutes will not even fix those lines. As you can see, Magoon, you claim a lot of bullshit. Maybe start trying to model in 3D instead of on a sheet of paper. And don't delete my video. Maybe you can delete your channel now, because I debunk all your glow bullshit.